In this video, we're going to go over section 2.3 exercises. So in the first question, we want to identify what are the premise and the conclusion for each of these arguments. So on the first question, we have all cats are mammals. Fluffy is a cat, therefore Fluffy is a mammal. One of the things is that it's very easy to check what is the conclusion, because the conclusion is after a therefore. So this is our conclusion, and then we can say all cats are mammals are going to be our premise 1. Fluffy is a cat is going to be our premise 2. Similarly, in B, we have if it's snow, schools cancel, therefore it's snow. So this is our conclusion, and this is going to be our premise 1. This is going to be our premise 2. And the type of arguments that we have here is, of course, implications for the most part. So we want to pay attention to also the construction of those arguments. So for question number 2 says, write each argument in symbolic form and identify if this is a correct argument, a valid argument in the form that it uses. So notice here we have if I study, I will pass. I study, therefore I pass. So if this is if I study is a P, I will pass, Q. I study, then P again, and then therefore Q. So this is an argument of the form P implies Q. Then we have P, and then the conclusion is Q. So this is what we call modus ponens. This is the type of arguments. Now we have if it rains, then the game is canceled. If it rains, the game is canceled. And we're going to talk about this one being P, then this is Q. The game is not canceled, so we have not Q. And it didn't rain, then it's negation of P. So this type of argument is we have P implies Q, and then we have not Q, and then conclusion not P. And this is what we call the modus tollens. Now for C, we have I am hungry, therefore I am hungry or tired. So this is a much more simple argument. We have P here, and here we have P or certain Q. I'm tired is my Q. So here the symbolic form that we have for this argument is P, and then the conclusion is P or Q. Notice the therefore. So this part is the conclusion. So we have a P, and therefore P or Q is our conclusion. So this is what we call addition by disjunction. This is a disjunction argument as well. All right, so now question number 3, we want to use a truth table to determine whether this argument is valid. We cannot done this before, but we can go over here again. Because we want to check if an argument is valid, then we want to check all the premises. And that's one way to do it. So we're going to do PQ, P implies Q, and then Q, and then conclusion P. And so remember that this is the order true, true, false, false, true, false, true, false. And in P implies Q, we have true, false, true, true. Q once again shows up and is true, false, true, false. And P is true, true, false, false. So now remember that for an argument to be valid, every critical row needs to have the conclusion to be true. Now let's check which one are the premises. The premises is this one, premise number 1, P1, P implies Q. Premise number 2, we have Q. and this is the conclusion. Okay? So we gotta look for the critical rows. So what are the critical rows? Critical rows are where they have all truths on the premises. So we have this one and we have this one. And so now notice that in this first critical row, it seems to be okay. True, true. Then we have that the conclusion is true. However, on the last one, this second here has true and true, so it's a critical row. But the last conclusion is false. So this is gonna completely screw it up of argument, and this is an invalid argument. Now we do the same thing for P implies Q, negation of P, negation of Q. We do need a little bit more here because we do need P and Q, and then we do need the negations. But we're going to go with true, true, false, false, true, false, true, false. And then we're going to go with P implies Q, which is true, false, true, true. And we're going to go in the order of the premises. Now we're going to go negation of P, which is the other premise, and then the negation of Q, which is the conclusion. So premise 1, premise 2, conclusion, because that's what the therefore is for. So negation of P, then of course is going to be false, false, true, true. Negation of these values. Negation of Q will be false, true, false, true. And now let's take a look at the critical rows. So critical rows for the premises, we don't have one here. We have at the bottom. So we have this one, and immediately fails because we have a critical row that has the conclusion being false. Even if this one was okay, because one of them was wrong, then immediately it's invalid. Okay? All right, moving on. Now we're going to recognize and identify which of valid arguments represent each of these forms. So notice that we have P or Q, and so if we have P or Q and we use and we have that negation of P, or we have that essentially P is not true, then we have Q. This is what we call disjunctive syllogism. So this is the disjunctive property of syllogism, or you can also call it elimination. If you have P and Q and conclude P, then simply this is just conjunction elimination. Okay, now we have P implies Q, and then Q implies R, and then P implies R as conclusion. Notice that P implies Q, then Q implies R means that P implies R. This is transitivity. This is this type of argument. And last, we already saw this before here. P implies Q, we have negation of Q, then we got negation of P. This is the modus tollens. So these are some of the rules for arguments. Okay, so now let's go to question 6. And we want to determine if the following arguments are valid or invalid. And if invalid, we're going to name the fallacy. We have here, if the car won't start, then the battery is dead. So this is P and this is Q. The car won't start. So this is P. Therefore, the battery is dead. This is simply P implies Q. Then we have P. Then we get Q as conclusion. This is modus ponens, and this is correct. Okay. Now, if the car won't start, then the battery is dead. The battery is dead. Therefore, the car won't start. This is a P implies Q. Then we get Q. Then we're supposed to have P. This one here is again P. And this is invalid. This is called the converse error. We saw that in the definitions. Okay, so if I am Paris, this is P, then I am in France, Q. I'm not in Paris, negation of P. Therefore, I'm not in France, negation of Q. This is a P implies Q. Then we have negation of P, then conclusion, negation of Q. This is invalid here. Notice that this is also another way of the inverse error. This is using the inverse relationship, like P implies Q is equivalent to negation of P implies negation of Q. This is not correct. Okay. Now the last one, if I am Paris, then I am France. I'm not in France, negation of Q. Therefore, I'm not in Paris. This is actually valid, and this is something of the for P implies Q, negation of Q implies negation of P. This is the contrapositive. We've seen that these two things are equivalent. P implies Q is equivalent to negation of Q implies negation of P. So because that is true, then we're going to have that this is valid. Now, for number 7, we're going to consider the argument if n is divisible by 4, then n is even. N is even, then n is divisible by 4. We want to know if this argument is valid or invalid, so we're going to classify it as this is P, then Q, then we have Q, then P. Once again, this is invalid, and this is the converse error. Okay, so now C says, give a counterexample showing that the argument can have true premises but false conclusion. So one will be n equals 6. So for n equals 6, this is going to work out. Notice that we have that if we check 6 is divisible by 4. And so one of the things is like this, of course, is going to be false. This statement is false, but this is P. But remember that 6 is even, and this is true. So we have an argument of the form P implies Q. So this is P, this is Q. And P implies Q is false implies true, which is true. So the first premise is true. Now Q is 6 is even, which is true. So true premises, premise number 1, premise number 2. But at the same time, then the conclusion is going to be P, but P is false. Okay? So this is going to have true premises, but it's going to have a false conclusion. So the argument overall is not going to work out. Okay, so now says question number 8, write the argument in symbolic form and determine if it's valid. All students study hard. John is a student, therefore John study hard. Well, if I have s of x being x is a student, h of x is x is study hard, then we can see this as a universal argument of the form for all x, s of x implies h of x. Okay? And now we have John is a student, so we can kind of say s of John. This is my second premise. And then the conclusion will be h of John. Since John is one of the students, it validates the universal statement, and we can conclude this. So this argument here is valid. And once again, this is a P implies Q. We have P, then we have Q. This is a modus ponens type of argument. Okay, we'll continue more examples of this in the video number 2.